Okay, so now let's look at our employees table first. So select everything from employees, the employees table, and then run this file, and you can see our employees table. I already filled it with 10 employees because we need a lot of data for this lecture, for this particular video. So I filled it up with 10 employees. And you got all the employees. Now if you want to filter, you have the where clause, order by, limit, and all that. But there are also some aggregate functions. Now before I go to aggregate functions, let me talk about single row functions. Now single row functions means for each row you're going to get a new output. So for single row function we have one example that is called the year function. So over here we have joined at, we got the whole date, we got year, the month, and also the date, but maybe you want just the year. So what you do is select everything from employees, and then instead of select everything from employees, I'm just going to do select name from employees and select joined at from employees. So if I run, you can see I should get only two columns, the name column and also the joined at column. So again, you can see joined at, we got the whole date, we got the year, the month, and also the date. Now if you want only the year, you can use a single row function. So you got, just type year, year, and inside that you have to specify which column should be converted to year. So obviously it's our joined at column, so joined at. Now this line is kind of getting long, so I'm going to do like this. Okay, so select name and year, select name and joined at, but that joined at is wrapped inside the year function. So now this joined at, so this year function is going to extract only the year part and give us the year part. So let me just run it because it's much more easier to understand visually. So you can see we got, first of all, the column name is year joined at like this, and you can see we got 2020, 2019, 2016. So now instead of the whole date, we got just the year. So this is also a useful function. So one thing you can notice it that let me just copy this and paste it, and I'll remove the year function over here. Okay, so semicolon. If I run only this part, okay, you can see we got the whole date. Now we have 1, 2, 3, 4, we have 10 employees, and for each employee we have a joined at date, a joined at field. Now this year function, what it's doing is for each record, for each joined at, it's going to give us each year. So for every record, it's going to give us every year. So if you have 10 records, then for 10 joined ats, it's going to return 10 years. So obviously because each joined at is different. Then if you have 20 employees, then we're going to get 20 joined at, 20 year. So you can see we have joined at, we have 10 joined ats because we have 10 employees. But if I run this, you can see for each joined at, we are getting a new year. So this is called a single row function because for each row it's returning an output. So if you have 100 rows, then it's returning 100 outputs. So that's about single row function. We also have multiple row functions, or you can say aggregate functions. It's going to return just one output for multiple rows. So maybe you can do I'll just go here and select everything from the employees table. If I run this, now maybe you want the sum of all the salaries. So for website developer, the sum is 5,000, and for manager you have 1, 2, and 3 managers. So you have 3 managers. So maybe you want the sum of all the manager salary, and then you want sum of all the analyst salary. So for each job position, maybe you want the sum of salary just to look at how much we are giving. So for that we have aggregate functions. So aggregate or multiple row function. So first I'll start by using the sum function. So I'll just copy this and paste it here. Now I want only the job position and the salary, for example. You can see we got job positions, website developer 5,000, manager 3,800, analyst 3,200, analyst 3,150, like that we got. Now if you want to sum up all the salaries, you have the sum function. So sum and then the salary, like that. Now it's not going to work just yet. So if I run this, you can see we get an error because aggregate function need another clause, that is the group by clause. So group by, and then you have to group each of the sum. So now we want to group each sum by their job position. So I'll just show it actually what I'm trying to do. You can see we got an output like this. So now website developer, if you combine all the salaries of the website developer, you get $5,000. If you combine all the salary of the managers, you get $9,400. So like we had 3 managers. So like summing up all their salaries. Now analyst, you sum up all the analyst salary and we got 9,450. And we summed up all the salaries of the clerk and we got 8,800. So this is what happens. First of all, we are needing the job position column. So we got the job position column over here. And then we selected the sum of the salary. So now the salary is going to be summed up. But it's not going to be summed up like simply. We have to group it. So for each job position, it's going to return a new sum. So that's actually the function of group by. So group by job position means for each new job position category, we're going to get a sum. So you can see for each website developer, we added all the sum. For each managers, we added all the sum of the salary. So sum salary means we are adding all the sum and we are grouping them by job position. So each job position is going to have their own sum, not like the sum of all the employees. For each job position, we're going to have their own sum. That is about group by and aggregate function. So sum is an aggregate function because you can see we had like 10 employees, but we got only 4 outputs, and that too based on the job position. So for manager, we got only 1 output. For analyst, we got only 1 output. So instead of getting like 10 outputs, so you can see in the year, if I just run this, you can see for 10 employees, we got 10 outputs. But over here, we didn't get all the 10 outputs because it's aggregating. It's like giving us a function for, it's giving us a common output for all the employees, for all the records. So this is the sum. You also have average. So if I write average, so you can see a website developer on average, it makes $5,000. Managers, 3,133.3333. So if you add like all these salaries, if you take the average of all the salaries of the manager, then this is the average. If you take the average of salaries of all the analysts, you get this. You get this. And for all the clerks, the average salary is this. So you took the average salary, but you grouped it by job position. So for each job position, it's going to have its own aggregate. So for each job position, it's going to have its own average. Now, along with sum and average, you have min function. So min. So you can see the minimum website developer makes is 5,000 and the minimum a manager makes is 2,800. So you can confirm this if you select all the employees. You can see the manager 3,800. So this manager gets 3,800. This manager gets 2,800 and this manager gets also 2,800. So out of all these 3 managers, what's the lowest income? It's 2,800, right? And for all the analysts, so you can see this analyst is making 3,200, this analyst is making 3,150, and this analyst is making 3,100. So the lowest possible income of the analyst is 3,100. So if you just run this, you can see the minimum salary is 3,100 for analyst, and for manager the minimum salary is 2,800. So as we saw in the table. So this is the aggregate function. So for each group by field, so you can see we grouping by job position. So for each job position, it's going to give us the minimum. For last time we did the average. So for each job position, is going to give the average. So like that. And you can see the column name is min salary, just as we wrote over here. Now maybe you want some other column name. So if you remember, we had column aliases. So instead of min salary, we're going to output maybe like this. So minimum salary. Okay. So if I run this, you can see instead of min salary, we have minimum salary. Now it's not necessary that you should have only one aggregate function. So you see we have minimum over here, and maybe you want maximum also. So you can do like maximum of salary and as maximum salary, and I'll just put a comma over here, and if you can run and see, you can see the minimum salary a website developer makes is 5,000. The maximum is also 5,000. Minimum salary of a manager is 2,800. The maximum salary of the manager is 3,800. And along with min max, you can add like average also, you can add sum. So you can add how many aggregate functions you want. So that's about aggregate functions. Let's talk about the where clause a little bit. Now you're probably already familiar with the where clause because I've talked it in previous lectures, but I want to show one more thing actually. So it's not about where clause, it's actually about the aggregate functions along with the where clause. So it's actually pretty like logical, it's like you can easily understand it, but I just want to show it. So like, you know, from where clause you can add conditions, so only the records which meet the condition will be shown. So over here, if I type like where, no, first of all I'll just take a look at all our employees table. You can see we have all this. So now if I say like where the employee ID is equal to emp3, sorry, emp like this 00003. So if I do like that, obviously all the employee ID with only this particular employee ID will be selected. So over here we have obviously just one employee ID with this number. So if I run this part, you can see we get only one output. But if I say not over here, like this not, so this whole thing will be reversed. So instead of selecting only the employee ID with this particular ID, it will select all the employee ID without this. So instead of, so this will be omitted actually. So if I run this again, you can see we have 1, 2 and directly 4. And the third one is omitted. So that's actually like, you know, the where clause, you know it already. So I want to show you like what happens. So first of all, I'll just comment it out and run this again. You can see the third employee which we were removing is an analyst. Okay, so it's an analyst. So if we just remove it, this analyst should be gone. So the same thing actually, if we write over here, you can see if I run this part, you can see the sum of the website developer is 5,000. So if you add all the salaries of the website developers, you get 5,000. If you add the salaries of all the managers, you get 9,400. If you add the salary of all the analysts, you get 9,450. So what I want to do is, first of all, I'll just write it here for reference. Sum of, like a total salary of analyst, something like that. How much is it? It's 9,450. So 9,450, like that. Now if I do a where condition over here, like we did earlier, so I'll just copy this whole thing. Oops. Okay, like this. So we're doing like, we're selecting the job position and the sum salary. The sum salary is an aggregate function. Then we're grouping it by job position. But while selecting the two columns, we are omitting the third employee. So the employee ID with 0003 ID is going to be omitted, and we saw that earlier. So now what happens is, when we take the sum of it or any aggregate function, it's going to exclude this one. So now the sum, actually the analyst sum is 9,450. Like if you remove one analyst from the table, that analyst salary won't be counted, won't be summed up. So we should get a sum little less than that, less than 9,450. So if I run this part while excluding 0003, if I run this, you can see now the analyst salary is 6,250. So all the sum, like the salaries of all the analysts, whoever are there. So you can see the salary is 6,250. But before we had 9,450. Now why is it? Because we are excluding one analyst. So you are reducing the salary. That salary is not being counted in the total sum. So if you actually see all the employees, you can see the third employee has a salary of 3,200. So actually if you reduce 3,200 from here, you should get that. So 9,450 minus 3,200, like that. So I'll just copy this. You can see you got 6,250, and if you just run this part, you can see we are getting 6,250. So this where clause, you can also add it if you want to exclude or filter data, and according to that filtered data you want to get the aggregate sum or aggregate average or whatever. So where can be used for that? Okay, so now what if you want all the sum of the salaries only for people who have, no, like let's say first I'll put like an average salary over instead of like total salary, and I'll remove this where clause. If I run this again, you can see the average developer makes $5,000 and manager on average it makes 3,133 and analyst makes 3,150 on average. Now you can see we're getting all the job positions because we group by job position, right? So for each job position we are getting an average salary. But what if you want only job positions whose salary is greater than 3,000? So you can see only analyst, managers and website developers. So only these three people are making salary above $3,000, and a clerk is making actually below $3,000 on average. Okay, not all of them, like on average. So maybe you want only these three of them because they're making, their average salary is more than 3,000. So if you want like that, you might be thinking, okay, maybe we'll do where clause, like where, then what should we do? So we can do like where the average salary is greater than 3,000. So do you think this will work? So actually if I run this, it should not get an output. You can see invalid use of group function. So actually what's happening is because this where clause cannot actually do conditions based on the aggregate functions. Now before we did conditions like, where employee ID is this thing. So this thing is actually not an aggregate function, right? We are just filtering normal data. But you can see over here, we are using the aggregate function called the average. So we cannot put conditions based on the aggregate functions. So like you can see average, sum, minimum, maximum. So all of those are actually not possible with where. So if you still want to do like this, then we have another one that is called having. Okay, its having is very similar to where, but it's specifically designed for aggregation purposes. So now this having should actually come after group by, not before it. So like this. Okay, so now if I actually run this, you can see we got only website developer, manager and analyst. We didn't get clerk because the average salary of the clerk was below 3,000. But we put a condition that only we want job positions because we group by job position, right? So we want only job positions whose average salary is greater than 3,000, and clerk did not meet that condition. So it was not there in the output. Now if I put like more than 2,000, now obviously clerk was more than $2,000 on average. So if I run this, you should get clerk as well. Now if I put above $4,000, you can see only website developer is above $4,000. So you can see we get only website developer. So that's the difference between where and having. Where is like for normal conditions and you put it like after, from and before group by. But if you want to put conditions based on the aggregate functions like the average, the sum, the minimum or whatever, for that you have to use having. So this having and group by are like one part. So group by and like having are used for aggregation purposes. So that's about aggregation things, like how you can filter data based on like, how you can get a summary of a data, how you can analyze the data, like a lot of data into a few small summary. So you can see before we have like, over here we have like 10 employees. So if you want to get some meaningful data, you can create an aggregation yourself and you can filter data based on your needs. So over here we filter data like we want to get the average salary of all the job positions, but only on average whose salary is more than 3,000. So we got some meaningful data over here. So that's about aggregate functions. So this is aggregation, and this thing is a multiple row function or an aggregation function because we have average and this thing. So that's about average. We also have count actually. So if I put count over here, the count takes n star. So what happens over here is, first of all, I'll remove this. So over here, now if you see we have like 10 employees now, and we have one website developer, 1, 2 and 3 managers, and then we have 1, 2, 3 analysts, and we have 1, 2 and 3 clerks. So what this count is going to do is count is going to count all of those and is going to group by job position. Before we like took the sum of all the salaries or the average of the salaries and we grouped it by job position. So for each job position we got an average salary. So now for each job position we're going to get its count. So if I run this part, you can see website developer we have 1, managers we have 3 managers, we have 3 analysts, and we have 3 clerks. So this is actually the count aggregation function or the multiple row functions. So that's about multiple and single row functions. Now if you want, you can see you have count star. If you want to make it more user friendly, of course you can use as, and you can put like number of employees, maybe something like that. And oops, I just ran the whole thing. I'll just put like this, and you can see we got number of employees and job position. So the number of employees were grouped by job position, based on job position. So for each job position we got its count. Now if I put the sum of salary, then for each job position we're going to get its salaries, the sum of salary. So that's about grouped by and having, and if you want to use, you can use the where clause also. So that's about aggregate functions and grouping.